G'day and welcome to another one of my videos. What we're going to have focus on in this video is sketching quadratic functions and using the quadratic formula to help us sketch that quadratic function. The reason we'll use the quadratic formula is because sometimes these quadratic trinomials don't factorise nicely, so the quadratic formula can help us with that. So let's get started. Remember, there's 5 main things that we usually want to know when we're sketching a quadratic function to end up with our parabola. We want to know the concavity, so whether it's concave up or whether it's concave down. So if this coefficient of x squared is positive, it's concave up, and if it's negative, it's concave down. We also want to know where the parabola cuts the y-axis, known as the y-intercept. We just substitute in x equals 0 for that. We also want to know any x-intercepts, if any exist, or sometimes it might just touch the x-axis, so we can do that using the quadratic formula as well. And we just substitute in y equals 0 for that and solve. We also want to know the coordinates of the vertex, so where that parabola turns around, or its stationary point. And sometimes we want to know the axis of symmetry. So let's get started on how we do. But we can do these in another way around if we want to, or the order in these isn't really that important, but sometimes it's easier to do some steps before others. So our first example, y equals x squared minus 6x plus 4. Let's have a look at its concavity. Remember, we're looking for this coefficient of the x squared. So there's our x squared. What's the number in front of it? Well, it doesn't look like there's one, but there's actually a 1 in there. So the coefficient of the x squared is 1. Now that's positive. So if it's positive, it's concave up. So we've got a parabola that looks something like this so far. Now if I'm going too fast for you, don't forget that you can pause it, rewind it, etc. Okay, now let's find our y-intercept. So where does this parabola or quadratic function cut the y-axis? We just substitute in x equals 0 into this quadratic function. So 0 squared minus 6 lots of 0 plus 4, and we get y equals 4. So you'll notice that that's the same as that positive 4 on the end there. So we now know that the y-axis is cut when y is 4. So now let's find our x-intercepts, if any exist. We do that by substituting in y equals 0. So there we go, replace our y with 0, and I like to put it on the right hand side rather than having it first on the left hand side, but it doesn't matter. Now this doesn't actually factorise nicely, so what we're going to use then is our quadratic formula, which is this. Okay, you should have seen this before. So what we need to do is we need to know our a, b and c values coming up from here, our a, b and c values. So we look over here, our a value is 1, that's our coefficient of the x squared. Our b value is negative 6, and our c value is positive 4. And now that we have those three, we've got to substitute those into the quadratic formula there, but be careful with the negatives. Remember, I like to put them inside a pair of grouping symbols or brackets so that when we square it, we make sure we get the right answer. So we substitute in, we're going to simplify, so negative 6, square root of 20, so the discriminant here is 20, and 2 lots of 1. Now, what you really need to do is practice simplifying your surds and so on. So what we're going to do is the square root of 20 is the same as 2 root 5, and we're going to halve each of these. So a half of 6 will be 3, and a half of 2 root 5 will just be root 5. So we get 3 plus root 5 and 3 minus root 5 are our two solutions. So that's in exact form. But where would they fit on the x-axis? So what we can do is actually do those on our calculator. 3 take away root 5, and 3 plus root 5, and they will give us estimates of where they will be on our x-axis. So 3 take away root 5 is approximately 0.8, and 3 plus root 5 is approximately 5.2. That just makes it easier for us to estimate where the x-intercepts are. Okay, so that will make that easier. So let's go and find our axis of symmetry. Now, our axis of symmetry occurs at negative b on 2a. So we're using our same b and a values over here. Substitute those in, and we find that x equals 3 is our axis of symmetry. Excuse me. And then what we want to do is substitute x equals 3 into the equation, and what that will do is it'll tell us our y value. So we substitute that in, y equals negative 5, so the coordinates of our vertex are 3, negative 5, so our x value 3 and our y value of negative 5. So now we've got our 5 things that we need to be able to do our sketch. So let's do our sketch. To do that, we've put our important points. Our y-intercept was at 4. Our x-intercept was approximately 0.8 and 5.2. Coordinates of the vertex are 3, negative 5. And there's our axis of symmetry, so I do know that I can find another point by reflecting that over here. We don't have to have that axis in there in our diagram, but it can be useful just to making it easier for our sketch. And then we come up in a nice smooth curve going through all of those points. Makes it nice and easy for us. What we should also do is label our important points. So label our vertex and label our x-intercepts. And we've already got our y-intercept there at 4 is fine. So let's look at a second example. X squared minus 6x plus 10. Remember, we can have equations here that are not monic as well. So that just means whatever our a value here is, we make sure we substitute that in. So first thing, let's look at concavity. Again, the coefficient of x squared is 1, so it's positive, so it's concave up. Okay, so just be careful with that. Our y-intercept, we should be able to see that by now. It's just going to be our positive 10, but if we want to do all the process, let's substitute in x equals 0. Go and solve that. Y equals 10, so we know it cuts the y-axis at 10. And then we move on to our x-intercept. So substituting y equals 0, remember I like to put it on the right hand side, and again that doesn't factorise nicely, so let's go and use the quadratic formula. There it is, substituting our a, b and c values. So a is positive 1, b is negative 6, c is positive 10. So we substitute those in. Simplify it. This time when we do so, our discriminant, this part underneath the square root sign, ends up being negative. Well, in this course, we can't find the square root of a negative number. So if ever that happens, then what we find, there are no solutions for x. So what does that mean? Well, the parabola will not touch the x-axis. So we're going to have a concave up parabola, and our vertex here is going to be above the x-axis because it doesn't come down and touch or cross at all. Okay, so the parabola does not touch the x-axis. Alright, so that makes it a little bit harder, but not really. We can still find our axis. So remember that occurs at negative b on 2a. Substituting our a and b values from over here, and we find that x equals 3. So we do know that x equals 3 is our axis, and if we substitute that in to the original equation, we can find the the coordinates of the vertex. So let's substitute in our x equals 3, and we find that y equals 1. So that means the coordinates of the vertex are x equals 3 and y equals 1. So x equals 3 from up here and y equals 1. And that certainly makes things easier so far. Okay, so let's start to do our sketch. I've already put some important points there on already. Our y-intercept, our coordinates of our vertex. Now you'll notice, because I've already got my axis of symmetry drawn in there and the parabola is symmetrical, then I can reflect this point over here and make it easier for my sketch because I don't have any x-intercepts. So I've just reflected that point here over to here, and now we can then do our nice smooth curve coming down through the y-intercept, down through our vertex, and back up through this reflected point. And then don't forget, we can then label any important points. There's our vertex there, and no x-intercepts. So what we've actually seen there is our discriminant part in here. Whenever that's negative, our result underneath the square root sign is negative, our parabola sits either above the x-axis, or if it's concave down, it'll sit below the x-axis. And we've seen that whenever this is positive, then we get 2 x-intercepts. And if that's a perfect square, this discriminant part is a perfect square, then they'll be integer answers or integral answers. But if this is 0, if the discriminant is 0, then what happens is our parabola comes down and touches the x-axis. So it ends up being a perfect square. So it would factorise nicely. But yes, if we end up with that discriminant part in here, 0, for instance, we would have 6 minus 0 and 6 plus 0, which is the same result, and then dividing by 2. So what you need to do is practice, and you're going to get a fair few different types. So concave down, you're going to get concave up, you're going to get some that have no x-intercepts, some that will have just the one x-intercept, and some that'll be 2 x-intercepts and possibly surds. So you need to practice all of those and practice again, and that way you'll get better. So I hope you found this useful, and again, if you need to rewind it and look at it again to make it a little bit more clearer, but you really need to practice over and over and over again so that things become a lot easier and quicker for you. So thanks for watching.